Okay, students. So let's start with today's paper. Today we have to do October November 2023. This is an ATP paper, paper 4, variant 2. Chalo, let's start with this one. A student measures the spring constant K of a spring using two different methods. Perfect. The spring constant K of a spring is a measure of the stiffness of the spring. Perfect. The larger the spring constant K, the more difficult the spring is to stretch. Perfect. Okay, we know this. The larger the spring constant, the more difficult is the spring to stretch. Perfect. Method 1. The student measures the unstretched length of the spring nearest to zero point 0.1 centimeter. Whenever you have to write zero answers to zero point 0.1 centimeter, you have to write your answers till one decimal places. Whenever you have to write your answer closest to 0.1 सेंटीमीटर आपने अपने सेंटीमीटर के आंसर में क्या देनी है वन डेसिमल प्लेस परफेक्ट ओके measure the unstretched length L naught of the spring nearest to 0.1 centimeter. Do not include the loops at the end of the spring in your measurement. Perfect. So we will take a ruler and measure between these two dotted lines. I have already measured this and my answer is coming out to be 5.5 centimeters. Please, please, please keep the answer to zero point 0.1 nearest centimeter. Don't convert it into 6 or 5. Keep it till one decimal place in centimeter. The student attaches the spring to a clamp on a stand, ठीक है suspends a 300 ग्राम mass from the spring. ठीक है the student क्या कर रहा है भाई student यहाँ पे 300 ग्राम का mass suspend कर रहा है from the spring. The arrangement of the apparatus is shown in figure 1.2. Okay, so we have this apparatus. The student measures the new length L1 of the spring. L1 is 17.6 centimeter. Calculate the extension E of the spring produced by the mass. Use this equation. Okay, you have to calculate extension. How will you do that? Extension is equals to L1, that is 17.6, minus L naught, that is 5.5. Subtract both of them. 17.6 minus 5.5. What will this answer come out to be? 17.6 minus 5.5. This answer comes out to be 12.1 centimeters. Simple as that. This extension is 12.1 centimeters. Perfect. Calculate the spring constant K1 of the spring using this expression. We have to calculate the spring constant K1. How are we going to do that? So now we have to calculate the spring constant K1 of the spring. How are we going to that or do that? K1 is equals to 300 divided by the extension. Extension is 12.1. So 300 divided by 12.1. 300 divided by 12.1. This gives you an answer of 24.8. The answer for a spring constant comes out to be 24.8. Here I have written that. Okay, let's move on to the next one. It is important to avoid line of sight or parallax errors when determining the extension of the spring. Perfect. State what is meant by parallax error and how to avoid parallax errors. Okay. What is meant by parallax error, beta? Parallax error क्या होता है? When you basically जब आपकी line of sight, when your line of sight is not perpendicular, when your line of sight is not perpendicular to what? When your line of sight is not perpendicular to the measurement, that is basically causing parallax error. So let's write it here. You will say when line of sight is not perpendicular, not perpendicular to the measurement, not perpendicular to the measurement, parallax error occurs. Parallax error happens. Parallax error happens. Simple. Parallax error occurs. Perfect. How to avoid parallax error? Now, how will you avoid parallax error? Yes. How are you going to avoid parallax error? Yes. How are you going to avoid parallax error? Very, very, very easy. Now, how will you avoid parallax error? Very, very, very easy. Make sure that the line of sight, that the line of sight is perpendicular to the measurement. Perpendicular to the measurement. Simple. Acha, one thing that I feel you can add here is you can mention how will you do this. You can mention that you will place a vertical meter rule here, and then you can make sure that your line of sight is perpendicular to the meter rule. Simple as that. Maybe an eye like this. And you can mention this. You can mention this. You can say a vertical meter rule alongside the spring will reduce parallax errors. Will reduce parallax errors. Simple. Nothing complicated. Shallow. Let's move ahead. Okay, the student two. अच्छा student two different method use कर रहा है ठीक है. The other student is using a different method to calculate the value of K perfect. Pulls the 30 gram mass down by a small distance and release is it so that the mass oscillate up and down. Perfect. So बेटा जो second student है वो क्या method use कर रहा है? He is pulling down the 300 gram mass so that it oscillates up and down. Perfect. Measure the time t1 for 20 complete oscillations. सही है. The student is measuring the time for 20 complete oscillations as you can see here. Perfect. Record this time t1 in the table 1.1 to 1 decimal place. Okay, we have to record this time to 1 decimal place. So if you can analyze here, this is what? 13.58 seconds. If I convert it to 1 decimal place, if I limit it to this number, this will become 13.6. Perfect. 13.6. Perfect. This is the time for 20 oscillation. The student measures the time for 20 oscillation once more, okay, and records the time t2 in table 1.1. Perfect, we can see that. Calculate the mean time t for 20 oscillation and record your answer. We have to calculate the mean time. How will we do that? 13.6 plus 13.8 divided by 2, that is equals to 13.7. That is the mean time for 20 oscillations. Now, the mean time of the oscillation is the mean time period t of the oscillation is the mean time taken for one oscillation. Calculate the mean time. Okay, how will you calculate this mean time t? बहुत easy है बेटा. How will you calculate the mean time t for one oscillation? आप 20 oscillations के time को divide by 20 कर दो. 13.7 divide by 20. Your answer for one oscillation comes out to be 0.685. Your answer for one oscillation comes out to be 0.685. Now you also have to calculate the value of tu square. Let's calculate that. This is 0.469. 0.469 is your answer for tu square. The answer for t is also given. Simple, nothing complicated. Literally nothing complicated. Easiest thing possible on this earth. Okay. Use your value of tu square from table 1.1 to calculate the spring constant of the spring. Use the equation given. Okay, so we have to utilize this equation to calculate K2. How will we do that? 11.8 divided by tu square की value थी 0.469. Okay, 46 sorry 11.8 divided by 0.469. The value of K comes out to be 25.2, I would say. Yeah, 25.2 Newton per meter. Perfect. Explain why the value of mean time period obtained by 20 oscillations is twice more accurate than the value obtained by one oscillation twice. Very good. So explain why the value of mean time period T obtained by measuring 20 oscillations twice is more accurate than the value obtained by measuring one oscillation twice. Why is 20 oscillations twice measure करने से जो time period आ रहा है more accurate है compared to measuring one oscillation twice? Because whenever you measure a larger number of oscillation, what happens? The effect of reaction time decreases. The error due to the reaction time decreases. You can say it reduces. It reduces the effect due to a reaction time error. It reduces the effect due to reaction time error. Simple. Nothing complicated here. आगे बढ़ते हैं. Let's move ahead. It reduces the effect due to reaction time errors. Yeah, yeah, we have written this. आगे बढ़ते हैं भाई. और आगे देखते हैं इसका क्या सवाल है. A student investigates the rate of cooling of hot water. Okay, so rate of cooling of hot water investigate किया जा रहा है यहाँ पे. Perfect. ठीक है. Nothing complicated here. We are investigating the rate of cooling of water at the top and the bottom of the beaker of hot water. Perfect. The student measures the room temperature as 22.5 degree. Perfect. The student is measuring the room temperature as 22.5 degrees. Perfect. Nothing complicated here. The student is measuring room temperature at 22.5 degree, pours 200 cm cube of hot water into the beaker. Okay, so this is the hot water. Lowers the thermometer into the beaker until its bulb is just covered by the hot water as shown in figure 2.1. Perfect. He waits for approximately 30 seconds. Perfect. Starts a stopwatch and reads the thermometer. Perfect. बेटा student 30 seconds के लिए wait कर रहा है, then starts a stopwatch and reads the thermometer. The temperature on the thermometer at time t is equal to 0 is shown in figure 2.2. The temperature on the thermometer at time t is equal to 2. Time t is equal to 0 is shown in figure 2.2. Record the reading at time t is equal to 0 to the nearest 0.5 degrees. We have to record this reading. This reading is somewhere here. This will be what? चलो थोड़ा सा और zoom करते हैं. This is 85. The middle value will be 85.5. ये middle value क्या है? 85.5. Perfect. The middle value is 85.5. Perfect. So the reading on the thermometer is coming out to be what? 85.5. Perfect. तो इसको लिख लेते हैं भाई. Let's write it here. This is 85.5. Perfect. Explain why the student waits for 30 seconds before reading the initial temperature of hot water. Why the student waited for 30 seconds before reading the initial temperature? Yep. Why? Because the student wanted the thermometer to reach the temperature of the hot water. बेटा जब भी आप टेम्परेचर मेजर करते हो थर्मोमीटर से आप थोड़ी देर रुक के मेजर करते हो. Why? Because you want to allow the thermometer to reach the temperature of the hot water or the hot body whatever you are measuring. ये तो कॉमन घर में भी प्रैक्टिस होती है. तो यू विल राइट हियर to allow the thermometer to allow the thermometer to allow the thermometer to reach the temperature of hot water, to reach the temperature of hot water. Simple as that. Nothing complicated here. कुछ भी complicated हमने नहीं कहा. चलो let's move ahead. The student waits for 3 minutes. Perfect. The student waits for further 3 minutes. Okay. Reads the thermometer and records the new temperature reading in table 2.1. ठीक है. टेबल 2.1 में बेटा ये जो रीडिंग्स आई हुई हैं सेकेंड रो में दैट आर आफ्टर 3 मिनट्स. ठीक है. द स्टूडेंट देन रिमूव द थर्मोमीटर फ्रॉम द बीकर एंड पोर्स द वाटर अवे. ओके स्टूडेंट रिमूव कर रहा है थर्मोमीटर एंड पोर्स द वाटर अवे. He repeats the procedure in A but lowers the thermometer into the beaker so that the bulb is just above but not touching the bottom of the beaker as shown in figure 2.3. बेटा देखो थर्मोमीटर की पोजीशन चेंज हो गई. द पोजीशन ऑफ द थर्मोमीटर हैज चेंज. Now we are at the bottom. Where were we initially? Initially we were at the top. Initially we were at the top of the beaker. Now we are at the bottom of the beaker. Perfect, perfect, perfect. ठीक है. Record the initial and final temperature of water as shown in figure 2.1. Okay, so the initial and final temperature at the bottom are also recorded here. Perfect. Okay, okay. Calculate the average rate of cooling of the hot water at the top of the beaker. Use this equation. The average rate of cooling is the decrease in temperature divided by the time taken. Give your answer to two significant figures and state the unit. Perfect. So, if you have to calculate the rate of cooling at the top of the beaker, which temperatures are you going to use? Which temperatures are you going to use? These temperatures. Because these temperatures are the temperatures just below the surface. Can you calculate the change in temperature here? Yep, easy peasy. What will be the change in temperature here? The change in temperature will be 85.5 minus 78. This comes out to be what? This comes out to be what? 7.5 degrees. 85.5 minus 78. This comes out to be 7.5 degrees. Perfect. 7.5 degrees का decrease in temperature है perfect. और बेटा कितना टाइम लग रहा है? How much time is getting involved here? 3 minutes. Now it is my choice कि यहाँ पे मैं 3 minutes रखूँ या minutes को second में convert कर दूँ. I am keeping my time in minutes because I have the liberty here. This comes out to be 2.5 degrees centigrade per minute. Please remember this will be 2.5 degrees centigrade per minute. If you take the time in seconds, तो फिर आप आपका unit भी seconds में कर लेना please. Now here, I have done this already. You have to calculate the average rate of cooling of the hot water at the bottom of the beaker. If you have to calculate the average rate of cooling at the bottom of the beaker, which temperatures will you use? These. What will be the change in temperature? 86 minus 77, that is 9 degrees centigrade, is your change in temperature. What is the time that is utilized? 3 minutes. 9 divided by 3, 3.0 degrees centigrade per minute comes out to be your answer. Okay. Use your answer in B part 1 and B part 2 to explain. Okay, you have to use your answers in B part 1 and B part 2 to explain why a hot liquid should be stirred before measuring its temperature. Perfect. What a good little question here. Can you see the rate of cooling at the bottom is 3 degrees per minute? The rate of cooling at the top is 2.5 degrees per minute. Why should a hot liquid be stirred before measuring its temperature? Why should a hot liquid be stirred before we measure its temperature? So that the temperature throughout the liquid becomes equal. You can write it here. To make sure, to make sure that the temperature throughout the liquid becomes equal, that the temperature throughout the liquid, throughout the liquid becomes equal, throughout the liquid becomes equal. Perfect. Let's further move ahead. State one way in which the apparatus used in this experiment is arranged to make it easy to read the thermometer accurately. Now, I think I have discussed this in this paper as well. यहाँ पे मैंने डिस्कस किया था पैरेलैक्स एरर वाला सवाल. Yep. See, I did told you कि अगर आपने पैरेलैक्स एरर रिड्यूस करना होता है तो आप क्या किया करो, मीटर रूल को वर्टिकली यहाँ पे क्लैम्प कर लिया करो या लगा लिया करो. परफेक्ट. So similarly here, can you see? Can you see here in this experiment, they have made life easier for you. They have clamped the thermometer vertically, which makes it much more easier for the eye to read the readings on the thermometer. बहुत easily आप eye से यहाँ पे reading निकाल सकते हो. Simple. You can write this. You can write this. You can write this. State one way in which the apparatus in this experiment is made. How will you write this? You will say, okay, you can see that the thermometer is held in a clamp. This helps us avoid parallax error. Thermometer is held in a clamp or a stand. Thermometer is held in a clamp, which makes or which causes the or which helps us, or which helps us in taking a reading without parallax error. A reading without parallax error. Simple. Okay. Thermometer is held steady in a clamp. This helps us to avoid the parallax error. Simple. Let's further move ahead. The experiment is repeated to check the results. State one variable that must be kept constant. The experiment is repeated to check the results. State one variable which must be kept constant. बेटा कौन सा variable should be kept constant here? Throughout this experiment, which, if you are repeating this experiment, what variable should you keep constant here? First of all, you must keep the initial temperature of the water constant. The initial volume of the water should remain constant as well. These are the two variables that I can think right off the bat right now. Initial temperature and volume of water should remain constant. And volume of water should be constant. Simple. Initial temperature and volume of water. Yeah. Let's further move ahead. क्या लिखा हुआ है भाई? The student leaves the thermometer. Okay, the student leaves the thermometer in the hot water and waits for 30 minutes before reading the thermometer again. Predict a value for the temperature of the water in the beaker. Okay. बेटा देखो, कभी भी आपने कोई हॉट कॉफ़ी ली हो या हॉट चाय ली हो, आप उसको 30 मिनट तक या बहुत देर तक, 30 मिनट तो एक आर्बिट्री वैल्यू है, यहाँ पे कुछ भी हो सकता था. हियर वी कुड हैव 60 मिनट्स एज वेल, 2 hours एज वेल. लेट्स से यू हैव अ कप ऑफ टी और अ कप ऑफ कॉफ़ी, यू हैव प्लेस्ड इट just like that for 30 minutes without any cooling, without any heating. You have placed it in a room for 30 minutes. What will happen? The tea or the coffee ka temperature will fall to the room temperature. What is the room temperature in O level physics? 22.5 degrees centigrade. Simple. Let's further move ahead to this question. A student investigates how the potential difference across the terminals of a power supply changes as the current in the circuit changes. Perfect. The student assembles the circuit shown in figure 3.1. Okay, so the student is assembling the circuit shown in figure 3.1. ठीक है. You have a voltmeter, you have an ammeter, you have a power supply, you have a flying lead, you have an insulating tape, you have a resistance wire, you have a crocodile clip, you have literally everything in this world. Nothing else needed. The student closes the switch and observes the reading V naught on the voltmeter. Perfect. The reading is shown in figure 3.2. Okay, the reading is shown in figure 3.2. Record the reading V naught. What is this reading V naught? Let's see. This reading V naught is exactly coinciding with what? 2.9 volts. Let's write it here, 2.9. Perfect. Let's further move ahead. The student then connects the crocodile clips to the resistance wire at a distance of 100 centimeter. Okay. The student then connects the crocodile clips at this distance. This 100 centimeter पे crocodile clips connect कर देता है. ठीक है. From end X records the potential difference across the wire as 2.3 volts. Okay. So records the potential difference across the wire as 2.3 volts. Perfect. Record the currents in the wire and opens the switch. Perfect. The reading on the ammeter is shown in figure 3.3. So we have this reading on the ammeter. Now we will have to zoom in a bit if we have to read this out. This is 0.5. This will be 0.4. This will be 0.4, 0.3, 0.2, 0.1. Perfect. The needle is slightly above 0.3. Can you realize the needle is slightly above 0.3 at this value? Aha. At this value. At this value. This will be what? 0.31 ampere. Simple. This will be 0.31 ampere. You can write it here. 0.31 ampere is your reading of the current. Perfect. The student closes the switch, repeats B for the values of D 80 centimeter, 60, 40 and 20. अच्छा ठीक है. Student repeat कर रहा है experiment for different values of D, that is 40, 20, 80 and so on and so forth. 40, 20, 80, 60. Perfect. The student results are shown in table 3.1. Complete the header of each column. Include the value of I from B. Okay, so we can include the value of I. Okay, that is 0.31. And the header completion is also very easy. D is measured in centimeters, voltage V is measured in volts, current I is measured in amperes. Perfect. On the grid provided, okay, now we have to draw a graph again. Again, on the grid provided in figure 3.4, plot a graph of V on the y-axis, I on the x-axis using the data in table 3.1. Start both the axes from the origin, draw the line of best fit. Can you realize you have to start the axis from the origin? Yep. So one thing is catered for. Voltage will be on the y-axis and the examiner has already marked the axis for you guys. You don't have to mark the axes this time. Okay. You have to start from origin. So let's say this is 0. I think this is an easy graph. Examiner has done most of the part for you. Okay, now you have to draw voltage on the y-axis, current on the x-axis. Now let's choose a scale for the x-axis. Let's do the thing that we have been doing since eternity. Let's choose a scale for the x-axis. Can you realize the maximum value? The maximum value on the x-axis is 0.88. What is the minimum value? 0. Okay. How will you calculate the x-axis key scale? Easy peasy. The scale on the x-axis is the maximum value of x minus the minimum value of x divided by the number of boxes. Divided by the number of boxes. 1, 2, 3, 4, 5, 6, 7. What is the maximum value of x? 0.88. What is the minimum value of x? 0. Number of boxes are 7. Let's do this. 0.88 divided by 7. This gives you a value of 0.12. Okay, so you will have to plot 0.12 as each of your units, which doesn't seem a good scale. This doesn't seem a good scale. What can we instead do? What can we instead do? We can say that we can say that each big box will approximately represent 0.2. Perfect. This is 0.2 as well. This is 0.4, 0.6, 0.8, 1, 1.2, 1.4. This looks like a much better scale than the 0.12 wala. Okay. Now, how will you mark the scale in the y-axis? How will you mark the scale in the y-axis? Again, very easy. What is the maximum value in the y-axis? 2.3. Perfect. So let's do the working for the y-axis as well. Let's do the working for the y-axis as well. You can say y scale will be equal to the maximum value of y minus the minimum value of y divided by the number of boxes on y. Perfect. So how many boxes do we have on y-axis? 1, 2, 3, 4, 5, 6, 7. Perfect. 7 boxes on y-axis. What is y key maximum value? 2.3. Perfect. Minimum value is 0. 2.3 minus 0 divided by 7. 2.3 divided by 7. This gives you a value of 0.3. Yeah, 0.3 roughly. 0.33 you can say. But we cannot plot 0.33. Instead, we will plot 0.5. Instead, we will plot 0.5 because that will be a much more appropriate scale. Now, you can say that this is 0.5. This is 1. This is, you can say, 1.5. This is 2. This is 2.5. This is 3. And this is 3.5. You have successfully plotted the scale. Now you just have to jot down the points. Let's start putting the points here. So first point is current 0.31, Y 2.3. Okay, so the points are plotted here. As you can see, it cover half of the graph on the borderline. Like 50-50, half of the graph has been covered. This will always happen with you. You will always face a dilemma whenever the origin is, the graph is starting from origin. थोड़ा सा borderline पे ही graph बनेगा. Don't worry about it in the examination. Graph इसी तरह बनते हैं, ठीक है? It should cover 50% of the graph paper and it is covering 50% of the graph paper in both x and y directions. Yeah, that's perfect. You need nothing more. 1 second. We will start. Oh. Okay, so we will draw a line of best fit like this, maybe. No, 1 second. This. Okay, so here we have the line of best fit. It is passing through 3 points. One, two, three. One is above the line, one is below the line. Simple, nothing complicated. Let's move ahead. What we have the next question is the gradient of the line numerically equal to the resistivity of the power supply. Okay, resistance of the power supply. Calculate the gradient of the line. Show clearly on your graph the value you choose and show your working. Perfect. So beta we have to calculate the gradient of the line. अब हमने gradient of the line निकालनी है. How will we do that? Very, very easy. First of all, choose 2 points. Choose 2 points that are maximum away. So maybe you can choose this point. Yeah, this looks good. Let's choose this point. Uh, this one. Uh, this one is 1 second. Let's mark it. 0.9 and y axis में क्या है ये point? Y axis में this is 1.1. Perfect. 1.1 in the y axis, x axis में 0.9. ठीक है, clear. Let's choose another point here. Hmm, which one can we choose here? We can choose the starting point because the line is passing through this starting point. Let's choose this point as well. This point was what? This point was 2.3 and 0.31. ठीक है, 2.3 and 0.31. This is 2.3, 0.31. Oh, 0.31 and 2.3. So you have your 2 points. Again, you can draw a triangle that is preferred. If you don't want to draw that, that's also perfectly fine. But I would draw a triangle if I had extra time in the examination. 1 second. 0.31, 2.3. 0.31, 2.3. The next value was 0.9 and 1.1. Perfect. 0.9 and 1.1. Can we calculate the gradient here? जी बिल्कुल. Gradient is equal to y2 minus y1. 1.1 minus 3.2. x2 minus x1. That is 0.9 minus 0.31. Perfect. Let's calculate this answer. 1.1 minus 2.3 divided by 0.9 minus 0.31. This comes out to be negative 2.03. Yep, this is your answer. Negative 2.03 is your gradient ka answer. Yeah, that's your answer for the gradient. Simple as that, nothing complicated. कुछ भी complicate हमने नहीं किया इसमें. Simple रखा है ग्राफ को और gradient को. The intercept between the y-axis and your line is the electromotive force of the power supply. Extend your line of best fit to meet the y-axis and write down the V naught. देयर इज अ रीजन कि आपका ग्राफ एग्जामिनर इतना सही बनवाता है ताकि फिर उसको एक्सटेंड करवा सके एग्जामिनर. नाउ एक्सटेंड दिस एंड लेट्स सी वेयर इट मीट्स द y axis properly, please, properly. Yep, very good. OneNote is behaving good today. So what will this value be? This value is roughly around what? This will be 2.9. This will be 3. This is somewhere 2.9. You can write 2.92 or you can write 2.93, whatever you want to write. I am choosing 2.92. I am choosing 2.92. Let's write it here. There is no specific reason for that. Just because I think the graph is more toward the downside. 2.92 is your voltage value. Perfect. Nothing complicated here. चलो आगे बढ़ते हैं बेटा. Now, what do we have to state? What do we have to state? ये क्या चीज़ अब हमने solve करनी है? Let's see this. What do we have here? Compare the values of V naught in A with the V naught you determined from the graph. Okay, what was the value of V naught in A? Wow, we did determine V naught in A. Chalo. V naught in A. That was 2.9. Wow, that's pretty close. That's pretty close. Wow, good graph. V naught in part A was 2.9. हमारा V naught graph से आ रहा है 2.92. This is from the graph. This is from the part A, you can say. The quantities are considered to be equal within the limits of experimental accuracy if the values are within 10% of each other. State whether your two values obtained for the electromotive force are same. Support your conclusion with a calculation. How do we do the calculation for this? I have told you multiple times now. Percent difference in voltage निकालने, तो what will we do? Larger value of voltage minus the smaller value of voltage divided by what? Average value of voltage multiplied by 100. What is the larger value of voltage? 2.92 minus the smaller value 2.9. Take an average of this. 2.92 plus 2.9 divided by 2. This will be 2.91. Perfect. Multiplied by 100. What does the answer come out to be? 2.92 minus 2.9 divided by 2.91 multiplied by 100. This comes out to be 0.68%. That is pretty less. 68% is very less. So you will say both values are same. Both values are same. Why? Because percentage difference is less than 10%. Because percentage difference is less than 10%. Less than 10%. Simple, nothing complicated here. Let's move ahead. I think this question should have. No, we have another part. Very good. Another student decides to connect the crocodile clip in figure 3.1 so that there is only a very small length of resistance wire included in the circuit. The teacher tells the student not to do this. Yes, the teacher is very, you can say, and this she understands physics. Okay. The suggest one practical reason why the value of d less than 20 centimeters should not be used. Let me show you why. Can you realize that as the value of D is increasing, D is decreasing, what is happening? The value of current is increasing. As the value of D is decreasing, the value of current is increasing. Perfect. So if you make D lesser than 20, beta अगर D आपने less than 20 कर दिया तो the current की value will get too high. If the value of current is too high, that means what? Your circuit will get heated up. You can write it here. You can write it here. You can say for values of D, for values of D less than 20 centimeter, the circuit or the current values get too large and the circuit heats up. And the circuit heats up. Simple. Circuit heats up. Simple, nothing complicated here. Circuit heats up, or you can also say the wire heats up. Anything works here. Wire heats up. Why? Because the current in the circuit becomes too large. Perfect. Is it possible to change the potential difference by? It is possible to change the potential difference by using a variable resistor rather than different lengths of resistance. Why? Perfect. Complete the circuit diagram in 3.5 to show how the variable resistor will be connected. Very easy. Somewhat like this. This is your variable resistor. Perfect. And you close this. Voltmeter will be connected in parallel here. Perfect. Voltmeter is connected in parallel. Variable resistor का symbol हमने बना दिया है. That's it for this question, I guess. I hope we have no more parts. We are on part H of this question. What a gigantic question. Let's move ahead. A student investigates the average speed of a trolley moving along a horizontal bench. Perfect. So we are investigating the average speed of a trolley moving along a horizontal bench. Perfect. The trolley is placed on a ramp and released from rest. Perfect. Some of the apparatus used in 4.1 are shown. Some of the apparatus used in figure 4.1 are shown. Perfect. What are the apparatus that we are using here? We have masses, we have stands, we have trolleys, a ramp, and a bench. Okay. The stopping distance of the trolley. Okay, so we are investigating the average speed of a trolley moving along a horizontal bench. Perfect. We are investigating the average speed. The trolley is placed at a ramp and released from rest. Okay, so it is released from rest here. Some of the apparatus used is shown in figure 4.1. Perfect. The stopping distance of the trolley is the distance traveled or distance moved by the trolley from the bottom of the ramp until it comes to rest. Perfect. Plan an investigation. Plan an experiment to investigate how the average speed of the trolley along the bench until it comes to rest depend on its mass. बेटा हमने बताना है कि how the average speed of the trolley along the bench depends on the mass that you attach on the trolley. Okay, basically listen the question. The question क्या कह रहा है क्या Question is trying to say कि जो average speed of the trolley है before it comes to rest depends on what? Depends on the mass of the trolley. This is what we are trying to investigate. The average speed of the trolley can be calculated using the equation shown. Average speed is equal to the stopping distance divided by time. Perfect. Explain briefly how to carry out the experiment, stating any additional apparatus needed. I can already see some additional apparatus that I will need. First of all, बेटा जो stopping distance आप measure करोगे at the bottom of the ramp, the stopping distance that you will measure, you will need a meter rule for that. Perfect. Secondly, you also need a stopwatch to measure the time. Stopwatch भी आपके पास नहीं है भाई. Stopwatch भी चाहिए होगी आपको to measure the time. Okay. And how will you carry out this investigation? And you also need one more thing. You also need a top pan balance. Why? Because you will be measuring the different amount of masses that you put on the trolley. तो masses measure करने के लिए एक top pan balance भी चाहिए. Perfect. Briefly explain how to carry out the investigation and state any other apparatus needed. Perfect. So how will you carry out this experiment? You will take the trolley and place it at the ramp. ठीक है. And you will measure different masses of top pan balance. You will place it here and you will release the trolley. You will measure the distance it takes to come to rest. You will also measure the time. You would have started a stopwatch. देखो basically experiment किस तरह होगा, let me explain. So you have a trolley. Let's say you will release it at point A. You will release it at point A. ठीक है? With a certain amount of mass which you have already measured from the top pan balance. Then, as the trolley releases, it will come to rest, let's say at point B. You will measure the distance from the bottom of the ramp to point B. You will also measure the time taken for the trolley to travel from the bottom of the ramp to this point B. Distance and time will be measured here. You can calculate the average speed. Mass is already calculated using a top and balance. So let's start writing this. Let's start writing this. You will say, okay, so you can start by saying that release the trolley. Release the trolley along with the mass, along with the masses from a specific point, from a specific point. Perfect. अब क्या बताओगे? You will say measure the masses using a top pan balance. Using a top pan balance, basically you are incorporating additional apparatus wala point or procedure wala point एक साथ. Measure the masses using a top pan balance. Secondly, you will say measure the distance. Measure the distance. This is a U, sorry for my writing. Measure the distance the trolley travels. The trolley travels from the bottom of the ramp. From the bottom of the ramp until it comes to a stop, until it comes to rest, you can say. Comes to rest. Perfect. Let's label this distance as d. Perfect. Okay. Measure the distance the trolley travels from the bottom of the ramp until it comes to rest. Measure this distance using a meter rule. Measure this distance using a meter rule. Perfect. What else do you need to measure? Measure the time to travel this distance using a stopwatch. Measure the time to travel this distance using a stopwatch. Perfect. Nothing complicated here. Now, do you remember whenever you are explaining an experiment, you always write one thing? What will you say here? You will say, repeat the experiment with different masses added onto the trolley. Repeat the experiment with different masses added onto the trolley. So let's write it here. Repeat the experiment. Repeat the experiment with different masses. With different masses added onto the trolley. Added onto the trolley. Perfect. Nothing complicated here बेटा कुछ भी complicated नहीं किया हमने. Now, state the key variables to keep constant. Which variable should we keep constant here? Yes, which variable should we keep constant here? Firstly, the one thing that I can see that should be kept constant is the height of the stand. Beta हमेशा 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 the height of the ramp, I would say. The height of the ramp will remain constant. What else? The release point, as I have mentioned it as well, you will always release it from a specific point. Let's say A in this scenario, the release point should remain same. And the type of trolley should also be the same every time. So you will say the height of the ramp, the height of the ramp and the type of trolley should remain same. And the type of trolley should remain same throughout the experiment. Throughout the experiment. And if you are really aiming for that A star or a distinction, you will also write an interesting point and twist it in a way such that examiner is really amazed with your writing skills. You will say, place a fusidal marker, place a fiducial marker on the RAM and always release the trolley from the same point. The trolley from the same point. Simple. From the same point. Perfect. Last thing that left, I guess. Draw a table with column headings. Explain how to reach a conclusion. A table with column headings is pretty interesting in this experiment. Always remember, beta, whatever you measure in the experiment goes inside the table. So you will write mass slash grams. Then you will write distance slash meters. Then you will write time slash seconds. And then you will write the speed slash what? Speed. Or you can say average speed. I would say you should mention the entire variable, that is the average speed. Let's make this a bit bigger. Oh, let's make it a bit bigger from here. You will say average speed slash ms minus 1. Perfect. Now, how to draw a conclusion? Plot a graph. Plot a graph of mass against the average speed. Or what else can you write here? What else can you write here? Compare the readings. Or you can say, or compare the readings. Compare the readings. Or to see. Compare the readings to see if mass affects the average speed or not. If mass affects the average speed or not. Simple. Nothing complicated here. This is what you will write here. This is the end of the paper. If you have any questions, you can ask in the comments or the chat.